All right, we're gonna start our next lesson, and these are skills for quadratics that you're gonna need in moving forward in this class. So we're gonna talk about factoring, and we're gonna start from bare bones and then build on that. So we'll start with the definition of what a factor is. A factor is a number of quantity that when multiplied with another produces a given number or outcome. All right, so I'm gonna give examples of factors of these three quantities. All right, so what are the factors of 24? Now there's a couple of different ways to do this. Okay, you can straight up think, okay, what are two numbers that multiply to 24 and then create your list. But I have a systematic way of doing it. I learned it in middle school, way back when. I won't tell you when that is, by the way. But way back when, and it works for me. So this is the method. I call it the rainbow method. I don't know the true name of it. But we start with 1. 1 is a factor of all numbers. All right, so 1, and then out over here, I'm going to put a 24. Okay, because I don't know how many different factors are between 1 and 24, but I know those are the ends of my list of factors. And I like to draw a little arc that connects those two, saying those two go together and make 24. All right? So then I go up to the next. Does 2 go into 24? Well, yeah. 2 and what number go into 24? 2 times what number make 24? And the answer to that is 12. I connect that with another arc. All right? Then I go up the list. Does 3 go into 24? Yes, 3 goes into 24 8 times. So 3 and 8 are factors of 24. And then I go up the list to the next one. Does 4 go into 24? Yes, it does. And it goes in 6 times. Right? So then I go to my next number in the list, which would be 5. 5 doesn't go into 24, so my factoring is complete. 1, 2, 3, 4, 6, 8, 12, and 24 are all the factors of 24. All right, so that works with any number. You can use this method, and it does work. And you can see it's called I call it the rainbow method because these arcs form sort of a rainbow. All right, so what about the factoring of algebraic expressions? How do we factor this? Well, we just expand using the rules of exponents. So x squared is x times x. So the factors are x and x, and then y to the third is just y, y, y. Okay? What about when you have a number mixed with a variable, a letter? Well, you first start with the factors of 10. So the factors of 10 are 1 and 10, 2 and 5, 3 and 4 don't go into 10, so that's my complete list. And notice I didn't make the rainbow. You can if that helps you. Make that rainbow to make sure that you've got the complete list. Okay, you know when to stop when you reach the other number, like 3 and 4 will be the next numbers after 2. They don't go in, and then you're back to 5, and you already listed that, so you can stop. All right? So we still have to have the factors of x squared, which is x and x. So in order to factor in algebra, you need to understand how we factor numbers, and not just numbers, but algebraic expressions as well. All right, so we move on to the greatest common factor, which I'm going to represent with the acronym GCF. All right, a greatest common factor is the largest shared factor of 2 or more quantities. All right, and I'm about to do some examples of finding the GCF. All right, so we're going to find the GCF in these 3 examples. So to find the GCF, all you need to do is create a list of the factors of each quantity, and then see what's the largest factor they share. So the factor list of 5 is short. It's just 1 and 5. What do we call numbers that have factors of only 1 in itself? We call those prime numbers. And in fact, 5 is prime. This is y. Okay, the factors of 45. So start with 1 and 45. Okay, does 2 go into 45? No, 45 is odd, so 2 doesn't go in. 3, does 3 go in? It does, and it goes in 15 times. Okay, does 4 go in? No. Does 5 go in? Yes, 5 goes in 9 times. And then go up the list. Does 6 go into 45? No. 7, no. 8, no. And then we're back to 9. So that is your complete factored list of 45. So then you compare the two lists and you look for what's the largest number they share. And the largest number they share is 5. So the GCF of those two numbers is 5. All right, moving on, the next one. We have 16x squared and 42x. All right, so I'll start with 16x squared. I'll factor that out. So we have a factor of 1 and 16, 2 and 8, 3 doesn't go into 16, 4 goes into 16 4 times. And that's the complete factorization. And then we have x and x for the factoring of x squared. So then we also have 42x. So what are the factors of 42? Well, 1 and 42, 2 and 21. Okay, 3 and 14. 4 doesn't go in, 5 doesn't go in, 6 and 7 go in. So there are the factors of 42. There's more factors of 42. So we also have an x. So now when you're finding the GCF, you look between the lists. You first look at the numbers. What's the largest number that they share? Well, they both share 2. Is there anything higher than that? No. So 2 is the GCF, but we also have to consider the variables. They both share a factor of x as well. All right, so our GCF is going to be 2 times x. So our GCF is 2x. All right, next one. We have negative 12a squared b. So let's start with the factoring of that. Now, when you have a negative, you can almost negate the negative if you're just finding GCF. Now, we'll talk about it later on when I have you factor actual terms that have like 2 terms in them, 3 terms in them. We'll talk about how you deal with the negative then. But for just finding the GCF, you can almost ignore that negative, all right? So all it means is that one of the factors is negative. That's all it means. So our factors of 12 are 1 and 12, 2 and 6, 3 and 4. Okay, a squared is a times a, and then we have a b. All right. And then 32ab. So the factors of 32 are 1 and 32, 2 and 16. 3 does not go into 32. 4 goes into 32 8 times. 5 doesn't go into 32. 6 doesn't go into 32. 7 doesn't go into 32. And then we're back at 8, so we're done factoring. Now I know this list looks a little weird, it's not evenly spaced, but that's okay. Okay? We still have all the numbers there. And then we're gonna have A and then B for our variables. So now look through that list and find the greatest common number, or the coefficient that is the greatest common factor. That's gonna be 4. Okay, then they both share a factor of A. So our GCF is 4A. Alright, so if the rainbow method of factoring doesn't work for you, for example, when we get to bigger numbers like, say, 48, and you got to know the 3 goes into 48 how many times, and it's not immediately available in your mind that 16 times 3 is 48, then maybe prime factoring would be a better method for you. So I'm going to show you that method with a couple of examples, and then just know that throughout the rest of this video, I use the rainbow method of finding GCFs, but you can also use this prime factoring method. So the prime factoring method relies on writing each of the numbers into what's called its prime factorization. So any number can be broken down into a product of primes. And the way you do this, there's a couple of different methods to do this. I use what's called the factor tree. So you start with your number. We're finding the GCF of 8 and 36, all right? We'll start easy. So I start with 8, and I think, okay, what 2 numbers multiply to 8? You can pick any 2, all right? Now, you don't want to pick 1 and 8 here, okay? Because that doesn't help you along in the tree. So don't use, if it's only 1 in itself, that means that that number itself is prime, okay? 8's an even number, so we can divide out a 2, and it's 2 times 4, okay? So I always circle my primes because you cannot create a branch off of that. You cannot split 2 down anymore into primes because it's prime itself. So 4 can be broken down into 2 times 2. So I have my primes listed there. So the factors of 8, or the prime factors of 8, are 2 times 2 times 2. All right? Now we do the same thing, but with 36, and 36 is a little bigger number. But now you break it down in a similar way. So 36 is even, so it can be divided by 2. So 2 times 18 is 36. 18, again, is even, so I can take out another 2. It's 2 times 9. And then 9 is 3 times 3. So 3's both prime. So the prime factorization of 36 is 2 times 2 times 3 times 3. So then to find the GCF, all you do is you you find the common factors in the 2 numbers. The GCF is then 2 times 2, which is 4. So that's an alternate method of finding GCFs, is what's called using the prime factorization. So what about if I add in variables like x squared, y squared? And to 36, I add in y squared. Well, you do the same thing that we did with the factor rainbow. You just put those factors at the end and say, well, 8x squared, y squared is just times 2x's and then times 2y's. 36y squared is just times y times y. So then the GCF, they share a couple factors of y. So my GCF is going to be 2 times 2 times y, which is just 2y. Just kidding, 4y squared. All right, so that is the prime factorization method. Feel free to use it. It works. All right, so for these examples, I'm asking you to factor the following expressions. So here are the expressions we're going to factor. So I would like for you to pause this video after I get done reading this and add this to your notes. You can always pause these videos at any time and copy down whatever I have written. I just write everything down to kind of speed up the video so that it doesn't last 40 minutes. All right. So the note I want to tell you is this: factoring is not solving. Repeat, factoring is not solving. You're not solving for anything. You're not going to get a numerical answer at the end. So what is factoring? Factoring is a way of rewriting an expression in a different form or in a different way. And we call that form the factored form. All right? The two forms are equivalent. So when we go and factor these expressions, my answer is going to be in a different form of this right here. But the two are the same. They're exactly the same. All right? And we're going to see that at the end. So let me repeat. Factoring is not solving. So if I ask you to factor something, I'm not asking you to solve anything. Don't add an equal sign and say it's equal to 0 or anything like that. I'm just asking you to rewrite the expression in its factored form. All right, so how do we do that? Move this a little bit. All right, what we do is we're going to find the GCF of these two terms. Okay? So we've done that. That was what the previous examples were about. So for this first example, I'll take it real slow and finding GCF and talking about leftovers and all that. But after that, I kind of want to just get to the method of factoring without all the extra stuff. All right, so bear with me on this first problem if finding GCF is like that for you. All right, so we want to find the GCF of 2x squared and 10x. So 2x squared, that factors to be 2x, x. Okay, great. The GCF of 10x, all right? So we have 1 and 10, 2 and 5, and then x. All right, so the GCF from this list, you can see, is going to be 2x. And in fact, I'm going to circle those two. All right? So, factoring, what we're going to do is we're going to factor out, which is akin to dividing. So factoring and dividing are almost the same word, okay? So you can think of factoring like dividing. So, what we do is we're going to factor out 2x from each of these terms. All right, or we're going to divide 2 out. So if we take 2x squared and divide 2x, because we're taking it, we're factoring it out, what are we left with? And the leftover is what's going to go in this first term. Well, if you look at our list here, what's left over is x. Okay, so where did this x come from? This x is 2x squared, what we started with, divided by 2x. All right, so you take the term that you started with, divide it by the GCF, and that's how you get what's left over. Okay, then there's a plus in between them, so there's still going to be a plus in between the two terms inside the parentheses. So then we have 10x divided by 2x. What's left over? Well, what's left over is 1 times 5. Or, excuse me, these terms are what's left over. Okay? So would it be 5 or 10 here? Well, you have to think about this. All right? If we started with 10x and divide out a 2x, 10 divided by 2 is 5, and the x's would cancel, so that's what's left over. All right? So again, just to make note, this number came from what we started with divided by the GCF. Okay? So, that is how you factor. I'm going to do one more and then ask a question out of it. I wanted to ask it here, but I'll wait till the next one. So same thing on the next one, all right? Without making the list, pause the video and see if you can get this GCF. So the GCF of negative 6x cubed and negative 15x, okay, is going to be 3x. Now, you might say, well, why didn't you take out a negative? I can take out a negative. And I'll show you that there's two ways to write the factored form of this. One with a positive GCF, or you can use a negative GCF. It doesn't matter, they're both the same. All right, so I'm going to stick with this positive 3x. I'm going to factor out 3x from both of these terms. So I'm going to have 3x. If I divide negative 6x cubed by 3x, I'm left with negative x squared. And then if I divide negative 15x by 3x, I get minus 5. And there's my factored form. Now, some of you might say, well, what if I wanted to factor out a negative 3x? Okay, well, that will lead to a different type of factored form, but again, it's still equivalent to this one. So if I factor out a negative 3x from both of these terms, what would I be left with in the first term? Well, negative 6x cubed divided by negative 3x, negative divided by negative is positive, 6 divided by 3 is 2, and x cubed divided by x is x squared. So I'd be left with 2x squared. Now, same thing with the second term. Negative 15x divided by negative 3x. Negative divided by negative is a positive. And then 15 divided by 3 is 5. And x divided by x, those cancel out. And there's the factored form. So both of those are the same thing as this form right here. So my question is this. How can you check yourself? How do you know whether your factored form is correct? You should never have to ask your teacher if your factored form is correct. Because what we're doing, and here's the answer to the question, what we're doing is we're basically undoing the distributive property. Okay, distribution is multiplication. So it stands to reason if factoring is division, that undoes the distributive property. So factoring undoes the distributive property. So to check yourself, all you'd have to do is take one of your answers and distribute. Okay, 3x times negative 2x squared is negative 6x cubed, and 3x times negative 5 is minus 15x. So that is exactly what we started with, so I know that this is correct. What about this over here? Negative 3x times positive 2x squared, that's negative 6x cubed. And negative 3x times positive 5 is minus 15x. So we see we get the correct answer there. All right, last example here. We have negative 6m squared times n squared plus 21m cubed. So again, I'm going to find the GCF to start. So the GCF of 6 and 21, that's where I start. I start with the numbers. So 3 goes into 6, which also goes into 21. 6 doesn't go into 21, so 3 is the coefficient. And then you look at the variables. This has m squared, this has m cubed, so m squared is going to be the GCF. 3m squared is the GCF. So in factoring, we have 3m squared. If I divide out 3m squared from negative 6m squared n squared, I have negative 2 to start, because negative 6 divided by 3 is negative 2. M squared divided by m squared is 1, so they cancel out, but then I still have that n squared. 21 divided by 3 is 7. And then m cubed divided by m squared is m. And there's my factored form. I hope these videos help you and that you actually do the practice for this, because these skills are super critical for moving any further in the advanced class. We have to get this down and pretty much to a point where you look at something and you can automatically tell what the GCF is right off the bat without creating any types of lists or anything like that. And the only way to get there is through practice. So please practice this stuff. Let me know if you have any questions, and I'll talk to you soon.